Here's another example of graphing parabolas, and this is example 4. F of x equals negative x squared minus 8x minus 16. So right away we can look at this, and these are the questions we want to answer. And among many we could ask, these are just some of them. And we could always find out when it's increasing, when it's decreasing. There's all kinds of things, about these functions you could ask. But first of all, we could look at this, and right away we can see that since it's got a negative in front, it's shaped like an N for negative. So that means it's opened down. So we could fill that in right away. It opens down. And we can see right away the y vertex is when x is 0. If I put 0 in here, remember the vertex is at 0 something. So when x is 0, whatever y would be, and that's going to be negative 16. So I can get my, sorry, that's the intercept. So that's the y-intercept, okay? So hopefully that makes sense. Just try to white out that other part. Okay, so those are questions we could answer just by looking at it, especially when it's in standard form. It happens real easy, but I think you could answer it even fast either way. So now we can, the intercepts, we have to find the vertex, I think would probably help us with everything else. So let's put this in vertex form. So I'll do that work on another page because it gets a little crowded over there, so it's a little bit bigger. And remember, we don't want anything in front of the x squared, so we have a negative sign there, so I'm just going to move it over to the left. So I'll multiply everything by minus 1, so this would be negative f of x, and a negative times a negative is positive, so that's going to make that x squared, positive 8x, and positive 16. So we multiply everything by negative 1. And now we have a nice form. And then we separate this out so we can complete our square to find the x value of our vertex. So I'll put the x squared plus 8x over here, and I'll move the 16 over here. And the square root of x squared is x, and remember half of 8 is 4. And what's 4 squared? That's 16. So I'm going to add 16 and subtract 16. And I noticed that I had a perfect square. This was a trinomial square, so it was already that. So I could have just made this 0 and saved a step, but just for the sake of continuity and doing it all the same way, we'll just say this is going to be squared. This sign goes here, positive, x plus 4. And remember, since we were on the right, if we add 16, we have to subtract 16 because it's on the same side of the equation, so we can add 0 to the same side. But 16 minus 16 is 0, so that means that and I just don't leave it blank. I put a 0 here because that's going to be my y. So my vertex will be the point negative 4, 0. And this is the vertex form. And you could write the 0 just to, like I said, forgot one thing, didn't I? Dadgummit. It won't change the vertex, but I forgot that I had a negative. So you got to write this stuff down. So if I multiply everything by a negative to fix that, then I have f of x equals negative x plus 4 squared and negative 0, but that's just the same thing. Negative 0 and positive 0 are the same, so it doesn't matter. So my vertex form would be like this because remember it's shaped like an N if I didn't make that adjustment. Kind of flubbed up there. It doesn't change the vertex, but it does change the shape of the parabola. So we know it's shaped like an N. So that's important. Excuse me. All right. So now we can fill in some of these other blanks here. Our vertex form is going to be f of x equals negative, and that was x plus 4 squared, plus 0, and then we can see that the vertex, all right, and the vertex is going to be the point negative 4, 0, and it's open down. Now, when we graph that, we put that point on here, negative 4, 0, we're right over here. Negative 4 and 0 up. And remember, the x-intercept is where the y is 0, the y-intercept is where the x is 0, so this is also the x-intercept. So we kind of lucked out there. And it's open down, so it's going to go like this, so there's only going to be one x-intercept. And we know what that is just by looking at the graph. That's going to be, the x-intercept will be -4, or x equals -4. And I usually like to write the point -4, 0. Okay? So it crosses at -4. And just like we could say the y-intercept is -16, but that's the point. So that's clear in your mind. Now, we don't have any other points on here to graph. We don't have any intercepts, so we're going to need 2 points. So it's easy to see the axis of symmetry. The axis of symmetry is going to be the x value. This is x and y. And the x value will be the axis of symmetry, so that's going to be x equals -4. So that's just this vertical line. But since it's open down, I'm just going to draw it down. All right? And you can see that it's going to be, well, we'll talk about the shape in just a second to determine the domain and range. But we need another point, or a couple of points. So we do have the intercept, but the intercept was -16. So in this case, I'm going to extend my graph. So you might have to do that. That's all right. Just make sure you have a ruler. It helps. And I'm just going to extend that line down a little bit. And I'll try to gauge it's the same as this is -10. So 11, 12, 13, 14, 15, 16. So that's -16. So I try to keep these about the same. And that's going to be my intercept, or the same length of these little squares. So I'm going to put that down. Oh, we can see it here. There we go. So you may have to extend it. Put a little arrow down there. So that's going to be my y-intercept. 0, x is 0, y is -16. And I do have this axis of symmetry, so since this is 4 units because this is -4, I'm 1, 2, 3, 4 to the right. I'm going to have another point, a symmetrical point, 4 units to the left. And that's going to be a -8, so I'm going to kind of just draw that line so I get it about right. So rulers are good. There we go. And then we have a symmetrical point, so I'll try to line that up. Gauge it off of this line here, so these lines are parallel, and then I can see that there's my symmetrical point right there. Something like that. And there's my point that's symmetrical to the y-intercept. All right? And that's going to be -8, -16. And now I've got 3 points so I can sketch it. All right, so you may, like I said, have to extend that. So if you sketch it, it's going to come down like this. Make it like a little curve there, a bowl, and then bring it down. So it comes something like that. And then the other way too. And I could find some points in here. I'd have to put them in the... And in reality, since there's just a 1 here, I'm just going to go over 1, down 1, and then over 2, down 4, 1, 2, 3, 4, because it follows the same pattern. So I'm fairly close actually. So you can get those points by using the basic shape equation. We haven't talked too much about that. But it follows that same pattern of x squared. But the intercepts are nice if you could do those. And like I said, we haven't talked too much about the actual shape equation using that. But if you look at this, since it's just 1x squared, it's just going to behave like y equals -x squared. It's just going to be from here. So x and y, so when x is 0, y is 0. That's my 0, 0 point here because it's shifted over. And then when x goes 1 to the right, I go down 1. So I go 1 to the right, I go down 1. If I go 2 to the right, I go down 4. Negative 2 squared is negative 2 squared is negative 4. So I go 2 to the right, down 2. So that's another way of getting some more points. All right? So go into that. Now we can look at this and now we can see that we do have a maximum value. The maximum value is 0, or y equals 0. That's as high as it goes is 0, and the value is the vertical position of the function. Okay, and the range of values, it's going to go from negative infinity all the way up to 0, so it's going to go from negative infinity up to 0, and including 0, so we have a bracket there. And the domain is all real numbers, negative infinity to infinity. So there we go. We've answered all of our questions. Okay? So I hope that makes sense.